This Lewis dot structure practice corresponds to page 30 of the bonding packet. So check it out. The first one, H2O. The first thing that you have to ask yourself before you draw a structure is whether the compound is ionic or covalent. The best way to tell is that ionic is going to be a nonmetal and a metal, and if it's covalent, it's going to be two nonmetals. So in this case, for water, H2O, it's going to be two nonmetals. Hydrogen and oxygen are both nonmetals. So once you figure that out, then you're ready to draw your structure. For a covalent structure, the first step is to count the number of valence electrons. So you have two hydrogens, and each hydrogen has one valence electron, and you have one oxygen. Oxygen has 6 valence electrons. So your total valence electrons for the whole molecule are going to be 2 plus 6, which is 8. Next, you draw your structure. We have 2 H's and 1 O, so I'm going to put the O in the middle, put the H's on the outside. The next step is to fill in your valence electrons until you've used up all 8. Right now I have 2 valence electrons. Remember, each bond is 2, so there's 2 right there, and there's 2 right there. So, but that's not enough. I need to have 8. So we cannot add any dots to hydrogens ever. That's a rule. You can only add them to non-hydrogen atoms. So let's add them over here. So now I have 2, 4, 6, 8 dots. I have 2 here. I have 2 here. Each bond is 2. So 2, 4, 6, 8. I've used all 8. So now I'm finished. So that's your structure for hydrogen. Next up, let's do potassium iodide. This is letter B if you're following on the worksheet. Ki. Is it ionic or is it covalent? Potassium is a metal, so it's ionic. These are a little bit easier for ionic. You don't really have to draw structures. You just have to draw the individualized Lewis dot diagrams for each one. Potassium is in group 1, so it has 1 valence electron. Iodine is in group 7, so it has 7. 1, 2, 3, 4, 5, 6, 7. And then you just have to draw an arrow showing the movement. This 1 electron is going to fill in right here, so that iodine now has 8. So iodine is happy. Iodine has 1, 2, 3, 4, 5, 6, 7, 8. And then your potassium you can just draw right next to it with nothing around it because it has donated its only electron to iodine, so it now has 0 valence electrons. So this is your final answer for potassium iodide. Nitrogen molecule, N2. Is it covalent or ionic? Nitrogen is a nonmetal, so if there's 2 nitrogens, that's going to be 2 nonmetals, so it's going to be covalent. Covalent means you have to count up the number of valence electrons and draw the structure. So let's do that. There's 2 nitrogens. Each nitrogen has 5 valence electrons for a grand total of 10 valence electrons. I always like to circle it so I don't forget how many I'm dealing with. Next up, you draw your structure and fill in your electrons. So we can put 2 here, 2 there, 2 there, 2 there. Sometimes you got to stop and make sure you don't have too many. 2, 4, 6, 8, 10. Up! I've already used 10. Look, let me show you. Here's 2, here's 4, here's 6, here's 8, here's 10. So I can't draw any more electrons because I've already used all of my electrons in the bank. But I'm not done yet because check out this nitrogen over here. It's still missing valence electrons. It only has 4, but it needs to have 8. Every element, except hydrogen, needs to have 8. So what are you going to do? Well, you can take some away from here. I'm going to erase these 2 on the top of nitrogen and turn them into a double bond. And then let me erase the 2 on the right side of nitrogen. Erase these 2 over here, and then I can make a triple bond. So now this nitrogen.
Anthony, please come to my office, please. Anthony, thank you.
This nitrogen has 8 electrons surrounding it, so it's happy. This nitrogen also has 8, so it's happy. I've used 2, 4, 6, 8, 10 electrons, so I'm good. We're finished. That's your final structure. Next up, ammonia, NH3. This is covalent. Nitrogen and hydrogen are both nonmetals. So I know it's covalent. So that means you count them up. Nitrogen has 5. Hydrogen, there are 3 hydrogens, and they each have 1, so that's a grand total of 8 valence electrons. Let's draw the structure. We have an N, we have 3 hydrogens, so I'm going to draw them around outside like this. Remember, you can never add electrons to hydrogens. So how many do I have right now? I have 2, 4, 6 right now in the structure. I need to have 8, so we can add the extra ones to the nitrogen. Finally, you got to make sure everybody's happy. Does nitrogen have 8? Yes. So we're finished. Potassium trichloride. The worksheet got a little bit mixed up in terms of format, so just follow along with my order here. Pi3, this is covalent, because they're both nonmetals. Let's count them up. Phosphorus has 5. There are 3 iodines. Each iodine has 7. That's a total of 26 valence electrons. Put your phosphorus in the middle. Put your 3 iodines around the outside. And now the next step is just to add our electrons. We've got to have 26, so I'm just going to go ahead and assume that I'm going to fill up all these iodines. They all need to have 8 valence electrons. So fill them in like that. Okay, what's my total count? Let's count them up. Right now I have 8, 16, I have 24. So I have 2 more in the bank. I got to put 2 more somewhere. Let's put them around the phosphorus. Now phosphorus is happy. He's got 8. Each iodine's happy. They have 8. So we're finished. Next up, CaI2. Be careful here. This is ionic because calcium is a metal and iodine is a nonmetal. So you draw your individualized Lewis dot structures. Calcium is in group 2 of the periodic table, so it has 2 valence electrons. You have 2 iodines. Each iodine is in row 7, so they have 7 valence electrons. So you draw 7 dots like that. Now, for the ionic structures, you got to draw the motion of the electrons showing your arrows, using your arrows. So the 1 electron from calcium is going to come over here and be the 8th one in that one, and one of them is going to come over here and be the 8th one in that one. So then at the end of the day, everybody's happy. So you can just do it like this. You can just do an iodine with 8, and then another iodine with 8, and then, I don't know, you can put your Ca over here. Doesn't really matter. And that's fine for a final answer of calcium chloride. I mean, calcium iodide. Alright. Aluminum, carbon dioxide, CO2. This is covalent because they are both nonmetals. Let's count up the valence electrons. Carbon has 4. There are 2 oxygens. Each oxygen has 6. It's a grand total of 16 valence electrons. Let's draw it. Put carbon in the middle. Put oxygen on the outside. So we got to have 16. I like to always start by adding them to the outside. That's the best way to start. Let me make sure I don't have too many here. 2, 4, 6, 8, 10, 12, 14, 16. Is that right? Well, okay, so I've used all 16 of my electrons, but take a look at carbon. Carbon's not happy yet. It's only got 4 valence electrons. Let me show you. It's got 2 here in this bond, and it's got 2 here in this bond. So a total of 4 valence electrons for carbon, but that's not enough. Everyone needs to have 8. So what are you going to do? Well, I can take these right here and turn them into a double bond, just like that, and then let me get my eraser and just erase those over there. So we're moving them. You can't just pull electrons out of thin air, but you can move them. Maybe we can do the same thing over here. On the left side, you can take these 2 and move them into that double bond, and then I'm going to erase where they used to be. So now, each oxygen still has 8. The carbon now has 8. I still have a total of 16 electrons, so I am finished. Next up, aluminum fluoride. AlF3. Careful here, aluminum is a metal, so it's ionic. So you got to draw your individual Lewis structures. Aluminum has 3 valence electrons. It's in group 3, so we give it 3 dots. And you have to draw 3 fluorines. Each fluorine has 7. 1, 2, 3, 4, 5, 6, 7. So each aluminum is going to donate 1 of its valence electrons to the fluorine to make it have 8, so that everybody at the end of the day is happy. So you can draw your 3 fluorines, each now completely happy with 8 electrons. And then you can just kind of draw your Al over here with nothing around it. off to the side, and that is a perfectly fine answer. The next one is oxygen, O2. Oxygen is a nonmetal, so this is going to be covalent. Let's count up the valence electrons. There are 2 oxygens. Each oxygen has 6 for a grand total of 12 electrons. The next step is to draw your structure. We have an O bound to another O. Now I've got to fill in my electrons to make it add up to 12. 2, 4, 6, 8, 10, 12. Is that 12? Let's count them. 2, 4, 6, 8, 10, 12. Yes, I have 12. But am I finished? No. Take a look at this oxygen right here. It's only got 6 valence electrons. It's got to have 8. So what are you going to do? Where are you going to get them from? You cannot pull electrons out of thin air, but we can borrow them. How about we borrow them from down here? What if we take these 2 and borrow them, put them in the bond so we make a double bond? Then I can go back and I can erase these because I've moved them into the double bond. So now I still have 12 electrons, but now each oxygen is surrounded by 8, so they are perfectly content. Magnesium nitride, Mg3N2. Mg3N2. You got a magnesium here, that's a metal, so I know that's ionic. I have 3 magnesiums. Each magnesium has how many? I gotta look at my table. Each magnesium has 2 valence electrons. I'm gonna draw one there. I'm gonna draw one down there. I'm gonna draw one over here. And then I gotta do how many nitrogens? 2 nitrogens. Each nitrogen has 5. 1, 2, 3, 4, 5. I'll draw another one right here. 1, 2, 3, 4, 5. Alright, so everyone's gonna donate, or rather the metals are gonna donate to the nonmetals so that they can have 8. So let me get my yellow marker here. This one can give them to this guy here. This one can give them down here. What else? This guy can give them over here. This one can donate this one over here. It doesn't really matter where you put them, as long as at the end the nonmetals have 8 and the metals have lost all of theirs. So then finally you would have 2 nitrogens, each with 8 valence electrons. And then you would have how many? 3 magnesiums with 0. Alright. I'm going to take a break here in the video and start over on a new one.